Okay. So the New Jersey barrier is commonly used during highway construction. Determine its weight per foot of length if it's made of plain stone concrete. So what we need to find essentially is the cross-sectional area of this first, and then we can multiply that by its unit weight, and that'll give us I'm assuming the pounds per foot. Something like that. So to sketch the side of this, it's going to look almost like this. It's going to come down. So we can break this up into shapes, kind of like this. Common shapes. And what we're left it with is 3 squares and essentially 2 triangles because these are mirrors on this side. They're the same exact thing. So 5 unique shapes, essentially. So to start with shape 1, which is the easiest to find, because it's a rectangle, it's just going to be 6 times 24, which is going to be 144 square inches. Shape 2 is going to go here, but we don't know enough to do shape 2, right? We need to know this internal length. So to find that, we actually need to find shape 4. So shape 4 is a right triangle whose height is 12 and whose theta equals 55 degrees. So if we remember our SOHCAHTOA, we have an opposite and we're trying to find the adjacent here. So tan 55, which is our angle here, tan, is going to equal our opposite, 12 degrees, over our adjacent, which is the angle we need to find. So what this gives us is 12. We're going to multiply each side by x. X goes away. And then we're going to divide each side by tan of 55. So now tan goes away and we're left with x equals this. So now our length here is going to be 12 divided by tangent of 55, which is 8.4. It's 8.40249, but 8.4 should be close enough. So let's think about this logically. If we multiply that times 2, that's 16. So we have a total length here of 16. Which means that 24, or the overall length, minus these two, which as we know, each of these is 8.4, totaling 16. We're left with just this here, so 24 minus 16.8. This one here is going to be 7.19 times 12. Length here of 7.19, height of 12. .34 inches squared, and if you look, it makes sense. It makes sense so far. Okay. We can just solve for shape 4 right now while we have it. Triangle is area is 1/2 base times height. We have a base of 8.4 and a height of 12. So just doing this 1/2 times our 8.4024 and then multiplying that by 12. Our area equals 50.41 inches squared. Now, remember we have to do 2 times the area. So multiplying this by 2, because there's 2 triangles, we actually have 100.829 inches squared. So what shapes do we need now? We have 1, we have 2, and we have these 2. So it's covered. That's covered. We need 3 and 5. Shape 3 is, well, goodness. We know it's going to be 4 times the height, but what's the height? Well, let's analyze triangle 5 now. It is another right triangle, but instead, this time, we are given boy, what are we given? So we know that this is the base. Okay, we've got our triangle, we have a square and another triangle, and we know that here is 4 inches. We know that here is 7.19. So what we need to do is 7.19 minus 4. And what this gives us is we're now taking this out of the equation. Okay. Now we just have these 2 lengths. 3.19. Now divide that by 2. This will give us the length for here, and then also the length for here, since it's equal on both sides, which that is 1.597. Divided by 2. And we also have this angle theta, where theta equals 75. So now, well, what do we want to find? Well, we need to find this here. So coming back to here, we have opposite over adjacent again. So the tan of 75 is going to equal x divided by 1.597. So we'll just multiply tan of 75 times our 1.597. And that gives us an x of 5.96. And knowing that the area of a triangle is 1/2 base times height, then if we do 1/2 of 1.597 times our 5.96, then we have an area equaling 4.76, and again, because there's 2 triangles here, double this area is 9.52. Much less area than the other one up here. Much, much less. I won't look too deep into that. Inches squared. And of course, we know this now. So if here, again for illustration purposes, if this is 7.19 and each side here is 1.59, that means what we have to do to find this, oh, this is 4. Saves me the trouble. It's a given. And then what's the height? 5.96. So 4 times 5.96. .84 inches squared. Okay, now what do we have to do to get the total area? We add them. 144 plus 86.34 plus 23.84 plus 100.829 plus 9.52. Goodness. I'm getting 364.54. And now for the last step. Let's come here and, boy, this is dead loads up here. What did they call this? They called this stone concrete, which is 144 pounds per foot cubed. So 364.54 pounds per foot squared times or no, sorry. This is just inches squared, actually. So this whole thing's going to have to be divided by 12 times 144 pounds per foot cubed. So this, because we're dividing it by 12, is actually going to be feet. So we're going to be left with pounds per foot squared. Oh. No, sorry. This is area. This is foot squared. So this is actually should be divided by 144 then, shouldn't it? So if we divide this by 144, and we multiply this by 144, then we have 364.54 pounds per foot. Let's hope this is right. There we go. Splendid.